38 billion metric tons. That's the number of carbon dioxide emitted globally last year itself, and it's only going to grow exponentially larger. You might think that recycling solves the greenhouse emissions problem, but you'd be completely wrong. Only 30% of recyclable waste in America truly ends up being recycled. Well, it is true that aluminum is also recycled, but around 65% is actually recycled. This unrecycled waste is later exported to foreign countries and incinerated. Greenhouse gases sooner or later pile up and is currently the largest threat to ecology. Researchers predict that if we don't act right now, more than 1 million species could go extinct in the coming decades. This proves why we need to focus on solving this issue. However, to combat this very critical issue, we have founded Kahari.
We created Kahari to revolutionize clean energy generation by turning aluminum waste into viable electricity through an innovative zero-waste microgrid solution. This addresses the critical problems of failing recycling programs, ineffective microgrid options, and high carbon emissions. We offer a sustainable and cost-effective alternative to traditional energy sources such as natural gas and solar energy. By converting scrap metal into energy on-site, Kahari not only reduces waste, but also provides a new renewable energy source that is environmentally sustainable.
Broader level, it's a trash can that uses aluminum waste to create hydrogen and therefore electricity. Now let's take a closer look at the contraption. Soda cans or aluminum waste enters through the input into what we call the preparatory chamber. Then it is pulverized to increase the sulfurous area. Sensors will allow waste to be filtered out. Additionally, any soft metal to be utilized by the smart bin is to produce hydrogen, and it will filter out that the specific metals such as hydroxide as the byproduct. Then it goes into the second chamber. The pulverized aluminum reacts with water, which triggers an exothermic reaction, resulting in hydrogen. To increase efficacy of hydrogen production, the surface area of the aluminum waste is maximized in the preparator. At any time, manual override can be initiated in case of abnormal temperatures or abnormal pH.
Hydrogen builds pressure in the reactor chamber, which pushes the hydrogen from the reaction tank into the storage tank. Also, the heat exchange mechanism between the reaction chamber and a compressor maintains the temperature in the reactor using the generated heat to compress the hydrogen. When Kahari's hydrogen capacity is full, it is then flushed into the external storage chamber to produce electricity. The waste will be at the bottom compartment, in which we call it the collector chamber, where the reaction's byproduct aluminum hydroxide can be flushed into the aluminum recycling facility. It can then be converted back into aluminum or used pharmaceutically. Finally, the hydrogen kept in the external storage will be converted into usable electricity in a fuel cell or microgrid. Either way, Kahari will retain scalability, so it can be designed to power units of any size.
Continue, we have a functional proof of concept, which validates our chemical process. The reactor bits of aluminum along with water undergoes a chemical reaction, which generates hydrogen. This hydrogen is then transferred into a tank, which you can see here. And as needed, the hydrogen from these tanks are later transferred into the fuel cell. And in the fuel cell, hydrogen and oxygen are combined together to create electricity. This electricity can then be used to power the light as shown above in this house.
We have eliminated the dependency on fossil fuels for energy generation. We have reduced energy storage costs significantly by using hydrogen instead of lithium batteries. And we have also raised energy efficiency by optimizing the chemical reaction of aluminum and water. Finally, we have created a zero-waste energy generation system using aluminum waste and a sustainable closed-loop system that minimizes carbon emissions. As you can see from the graph, Kahari is a more sustainable energy source compared to other popular energy options.
In the current market, we have customers who are already using solar panels, natural gas fuel cells, or recyclable programs. In Tier 1, we have non-renewable energy users in suburban or urban areas who are dissatisfied with the energy costs but haven't been able to switch due to the lack of proper alternatives. Tier 2 is non-renewable energy users who are in a developing or remote area and they're not able to switch due to a lack of infrastructure and affordable/decentralized solutions. And Tier 3, it's communities in underdeveloped or rural areas with no access to energy infrastructure or recycling programs.
We estimate our costs to be around $325,000. This is our progress and projections for Kahari. We are hoping to launch around April of 2027. We have applied to a few grants and are now waiting for the results. To conclude, Kahari will create sustainable energy, reduce waste, and lower carbon emissions. Our product will revolutionize the energy industry, providing a cost-effective and scalable alternative. Kahari improve lives and help the world become more sustainable. This is just the beginning of a blue ocean.